All right, let's get right into it. Welcome to This Explainer. Today, we're cracking open one of the most talked about, yet, let's be honest, widely misunderstood technologies of our entire generation. We are going way beyond the crypto hype to completely demystify blockchain. Whether you're working in finance, healthcare, or you really just want to finally understand what all those headlines actually mean, our goal today is to uncover the true mechanics and the massive potential of this tech. And spoiler alert, it goes way, way beyond just Bitcoin.
To really set the stage here, I absolutely love this quote from Edward Snowden. He famously said, "Blockchains are record-keeping backed by fancy math." It's brilliant because it literally strips away all that intimidating, dense jargon that usually scares people off this topic. When you peel back all the layers, at its absolute core, we're really just looking at a hyper-secure ledger system. It's simply a brand new way of recording who owns what and who did what without ever needing a middleman. So here's our roadmap for today. We're going to hit beyond the crypto hype, the decentralized ledger, blocks, hashes, and chains, busting some common myths, and finally, real-world applications. Let's dive in.
Okay, Part 1, the decentralized ledger. Think about how traditional record-keeping works for a second. Picture 4 people in a room, right? But only one designated person, let's call them the accountant, is actually keeping track of everyone's money in a single central notebook. If that one accountant decides to secretly fudge the numbers to, line their own pockets, the whole system is completely vulnerable. Now imagine a decentralized blockchain system. Same room, but instead of relying on that one potentially shady accountant, every single person holds a copy of the exact same ledger. If someone tries to spend money they simply don't have or alter a past record, everyone else's ledger will instantly spot that discrepancy and reject the false entry. So what does this actually look like in action? Well, data isn't just sitting in one giant, easily hackable central server. Instead, it's distributed securely across thousands of participants, we call them nodes, all over a global network. This structural shift is a real game changer because there is literally no single point of failure. It makes the network incredibly resilient against cyber attacks and any kind of forgery. Now, you might be wondering, how do we actually stop people from cheating the system? Well, the network relies on validators, or miners. Think of them like a massive classroom of students grading each other's tests, instead of just handing them all to a single teacher. These participants expend computing power to verify the complex math behind every single transaction. This ensures absolute accuracy before any final grade or record is permanently finalized on the ledger. Moving right along to part 2, blocks, hashes, and chains. So how do we actually build this unchangeable public spreadsheet? It all boils down to a pretty straightforward 4-step process. First, a transaction happens. Say you're sending money or transferring a contract. Second, that decentralized network of computers we just talked about verifies the details. Third, the verified transaction gets bundled into a digital block along with hundreds of other recent transactions. And finally, step 4, this full block is permanently sealed with a unique cryptographic code. Now, that seal I just mentioned, that's what we call a hash. You can think of it as a completely unique digital fingerprint for the block. The fancy math here uses algorithms to convert all the data in the block into a long, random string of characters. The sheer genius of a hash is that if a hacker tries to change even a single character of an old record, the entire hash changes completely. It's basically like altering one comma in a massive novel, and suddenly the entire cover of the book turns neon green, instantly setting off alarms across the entire global network. And here is where the actual chain part comes into play. Every single new block created contains the specific hash of the block that came right before it. This creates a chronological, completely unbreakable chain. Because they're all mathematically linked together, altering just one historical block would require recalculating the hash for that block, and then recalculating every single block that came after it, across millions of computers simultaneously. For all practical purposes, it is completely impossible to hack. All right, part 3, busting common blockchain myths. Let's clear the air on some persistent misconceptions. The absolute biggest myth you'll hear is that blockchain is just an untraceable haven for criminals. The reality? It's actually the exact opposite. Because a public blockchain is literally a permanent, unchangeable public ledger, digital forensic specialists can often trace and recover illicit funds way easier here than they ever could with traditional physical cash or opaque offshore bank transfers. The footprint is there forever. We also really need to separate the underlying tech from the tokens themselves. People mix up blockchain and cryptocurrency all the time. But look at it this way. Blockchain is the underlying distributed ledger technology. It's the highway. Cryptocurrency is simply the digital coin being transferred across it. It's just one type of car driving on that highway, and you can use that highway for a lot more than just digital money. Another huge myth is the idea that this operates in some rogue, Wild West ecosystem that will never integrate with traditional finance. Well, in reality, major financial institutions are already integrating digital assets and blockchain solutions right now, and they're doing it using the exact same strict security and compliance controls like anti-money laundering and know your customer protocols that you'd expect from your local neighborhood bank.
Which brings us to part 4, real-world applications.
We're seeing massive institutional adoption across the globe. With things like government-supported educational modules rolling out, we are way past the experimental phases here. This tech is becoming foundational. It's a massive shift in how we understand and manage data on a societal level. And the sheer variety of use cases is mind-blowing. In healthcare, a company called GuardTime is using blockchain to secure the health records of 1 million citizens over in Estonia. In government, Dubai has set the super aggressive goal to become a fully blockchain-powered state, putting public records and business registrations onto the chain. Companies like Provenance are tracking real-world supply chains to stop counterfeit goods, and Kodak is even tracking intellectual property rights for photographers. The applications are practically limitless anytime you need a verified, absolute record of truth. It's even making serious waves in the arts. Take Ujo Music, which was started by the singer-songwriter Imogen Heap. They're essentially building a fair trade system for the music industry. By putting ownership records directly on a blockchain, it empowers musicians to automatically track their own royalties and IP rights fairly and transparently. It completely removes the need for those costly middlemen. Now, I do want to throw out a pretty wild fact here to keep things in perspective, because it addresses one of the major hurdles of this tech, the number 159. Right now, the blockchain-powered Bitcoin network actually consumes more energy than 159 individual countries. Crazy, right? This is entirely due to the intense computing power required by all those validators and miners we talked about earlier. Solving those complex hashes takes massive amounts of electricity. It's a very real-world cost for this level of decentralized security, and for sure, it's a massive challenge the industry's actively innovating to overcome.
So, as we wrap up this explainer, I want to leave you with a thought to chew on. What actually happens when our world starts relying on pure, immutable math and code, instead of just hoping humans are honest? When contracts just execute themselves, when supply chains are perfectly transparent, and when ownership is undeniable? Think about how this massive shift from trusting people to trusting the math might completely reshape the foundations of trust in your own industry. Thanks so much for hanging out with me today, and I'll catch you in the next explainer.